Okay, today we're going to go over how we factor the difference of squares. This is chapter 11, section 5 in the AMSCO textbook that we have been using online. This covers AA19, identify and factor the difference of two perfect squares. So let's look at this, what this says here, the difference, meaning subtraction, of two perfect squares. So the difference of squares we've seen before, like x squared minus 16 would be the difference of squares. 25y to the fourth minus 100 would be the difference of squares, because this is a square term and 100 is a square term. So the difference of squares, two perfect squares being subtracted one from another. When you factor them, you get the product and difference of two terms. So we talked about this in the last lesson. So basically we're going back and forth. So the last lesson was how do we multiply those together, and now how do we bring it from the multiplied form back into the factored form. Okay, so when we have the difference of squares, like 9 minus x squared is the difference of squares, because 9 is a square number, and x squared is a squared number, or it's a squared term, and you're taking the subtraction of those two numbers. So basically what you do is you think about what are the two binomials that you multiplied in order to get the difference of these two squares. So you take the term that's here. So remember, we talked about the general rule of a plus b times a minus b, and we said that was equal to a squared minus b squared. Okay, so now what we're doing is we're being given the a squared, so in this situation it was 9, and we're being given the b squared, in this situation it was x squared, and we are asked to find the a and b. Okay, so the a in this case would be the square root of the principal square root of 9, which is 3, and the b would be the square root of x squared, which is x. So we put that back into the difference and sum of two terms. Okay, so let's try an example here. So let's say that we have y squared minus 36, and we are looking for the two binomials whose product got you that difference of squares. Okay, so essentially our a squared term is y squared, so our a term must be a, and our b squared term is 36, so our b term must be 6. So we take that information and we say, okay, so this must have been a plus 6 and a minus 6. Okay, so those are the two binomials that must have been multiplied in order to get that difference of squares. In the next example, our a squared term is 4x squared, and if I take the square root of that, that's going to be my a term. So the square root of 4x squared, with the square root is identical to the way that an exponent works, in that you can distribute the square root to all parts of the term. So we have the square root of 4x squared is the square root of 4 times the square root of x squared, so that's going to be 2x. Okay, so the square root of 4x squared is going to be 2x. Okay, so I know that's going to be part of these binomials. One's going to be addition, one's going to be subtraction. Okay, and we didn't talk about this before, but it doesn't matter if you put the subtraction or addition first in the binomials, because like with any product, you are allowed to switch them around because it's the commutative property of multiplication. Okay, so for the next thing we have our b term is 4, or b squared term is 4, so our b term must be 2. Okay, so we're going to put that here, and so 4x squared minus 4 is equivalent to the quantity of 2x minus 2 times the quantity of 2x plus 2. Okay, and for the last problem on this page, our a squared term is 100a squared. So our a term is the square root of that, and that's going to be the square root of 100, the principal square root of 100 times the square root of a squared. So that's going to be 10a. Okay, so that's the first part here. Whoops. should be 10a. And again, it doesn't matter if you put the difference or the sum first because it's the same thing. And our, let's see, our b squared term is actually just b squared. So our b term must be b. So it's going to be 10a minus b times 10a plus b. And that would have gotten you that difference of squares right there. Okay. Now we have 3 more examples. I should have labeled them 4, 5, and 6 here because they're the 4th, 5th, and 6th example in this lesson. Geesh. Okay, so that should be 4, that should be 5, and that should be 6. Okay, so our a squared term in this situation is 0.49y squared. So our a term must be the square root of that. Okay, that's the same as the square root of 0.49 times. So I'm breaking this product up, 0.49, and I'm breaking it up with y squared. Okay, so the square root can be distributed into a product the same way a exponent can be distributed into a product. Okay, so 0.49 is 49 hundredths. So if we're taking the square root of 49 hundredths, you want to think of that as the square root of 49 over the square root of 100, because like exponents, I can distribute a square root into the numerator and denominator of a fraction. Okay, so the square root of 49, the principal square root of 49 is 7, and the principal square root, the positive square root of 100 is 10. Okay, and so this right up here is 7/10 y. Okay, so that's going to be 7/10 y plus something and 7/10 y minus something. Okay, and so our b squared term is x squared, so it's not that difficult to figure out what b is. B must be x, so that's going to be the last thing there. So it's 7/10 y plus x times 7/10 y minus x. Okay, so you can see, use the method that we did before. Let's see, a squared in the next term must be 0.36 c squared, and so the a term must be the square root of that. Okay, and 0.36 is 36 hundredths, and 36 hundredths, if I take the square root of it, that would be the square root of 36 over the square root of 100, which would be 6 over 10. So you can write it like that, or you can write it as 0.6, which is 6/10, okay? So this is going to be equal to 0.6 c. The one above I left as a fraction. I could have also exchanged it into a decimal. So here, let me write it in another color here. This will be 0.6 c minus something, and 0.6 c plus something. And so our next one is similar to our one before, where you have a coefficient that's a decimal. So we have 0.64. So this is our b squared term. So 0. See. D squared. Okay, so b is going to be the square root of that. Alright, let's break it up into different parts here. Okay, 0.64, you might be able to already see that the square root of that is 8/10. And d squared, the square root of that is d. So here, I'm going to try to fit it in here. And this will be 0. Okay, so it's 0.6 minus 0.8d times 0.6 plus 0.8d. Okay, and our last one, we have 36/49 minus b squared. So our a squared term is going to be 36/49. So, so our a term has to be the square root of that. Okay, and so what we want to do here is take the square root of both numerator and denominator. That's going to be 6/7. Okay, so this is going to be 6/7 minus, we can already see that this is going to be b right there because we want to take the square root of it. And that's it. Okay, I think that's the last, oh, 2 more slides. Okay, so we have to express the area of each shaded region as a, the difference of squares, and b, the product of 2 binomials. So express the area of each shaded region. Now, this is a particular type of problem where you have to figure out, it's like the cube and cylinder problem we had a couple days ago, where you have to like cut one out from another. So first you have to find the area of the large square. Then you have to find the area of the small square. And then you need to subtract the area of the small from the area of the large, and that will get you the area of the shaded region. Okay, the large square area. So remember, the area of a square is the side squared. So the side in our case is 4r. So we want to square that. That's going to be 16r squared. And the area of the small is going to be, again, side squared. But in our case, that variable they use to identify the side length here is s. So actually the area of the s squared is just s squared. Okay, so we want to take the area of the large, which is 16r squared, and we want to subtract the area of the small. So when we do this, you can see that we arrive at the difference of squares. So right here we've answered A, express that as the difference of squares. Okay, now for B, it says express the area of the shaded region as the product of 2 binomials. So now we have to figure out how to write this as the product of 2 binomials. And we know, since it's the difference, that we're going to have the sum and difference of 2 terms as our binomials. So we want to take the square root of 16r squared to find out what a is. That's going to be 4r. And the square root of s squared is going to be s. So that's it. We have 4r plus s, times 4r minus s, it should be. Okay, so that answers B. Okay, and the last question asks you to do the same thing, so you can pause the video and try to figure out how to do this by yourself using what we did before. And then I'll go over it. So hopefully you've tried this on your own, but at this time, to see if you can figure out how to do the area of the shaded region. This is a common SAT question, by the way, so when you get to high school, they ask you to do problems like this all the time, the shaded region problems. So it usually requires you to find the area of 2 or more objects and subtract one area from another to find the area remaining. So the area of the large square is going to be 5m squared, but that's 25m squared. And the area of the small square is going to be 2s squared, that's 4s squared. To define the area of the shaded region, we have to do the large minus the small, which is 25m squared minus 4s squared. So that's the answer to A above there. And for b, they want you to express it as the product of two binomials. So the square root of 25m squared is 5m squared. You're going to have 5m squared here. One's going to be plus, one's going to be minus, and then 2s and 2s, because that is the square root of 4s squared. So that's the answer to B. Okay, and that's the end of the lesson.